Hello, this is Mr. Huff, and let me explain how we're going to measure the distance. So what we're going to be doing is we'll be working in a space where we can measure. And to do this, we're going to have a launch line where we start from, and we will have bars or some sort of way to measure across the space and straight away. So if you throw your airplane and it makes this big curve and goes over here, you don't measure from the landing point to the start point. You just measure these spaces. We're looking at the displacement from the start line. So in this case, this would be 10 feet, even though if you measure the distance between the start and where the aircraft first hits the ground is much more than that. So we're only looking at this because one of the design parameters is it has to fly straight. So let's take the second example. So if you start from here and your aircraft first hits the ground at this point, then you would measure 28 feet. So the idea is you want it to fly in a straight line. If it curves, we're only looking at that horizontal displacement. So another thing is you will need to work with a partner because you not only need to measure distance, but you also need to know time in the air. Stopwatches on your phone are useful for this. For collecting your data, I will have this glider evaluation form available for you to make a copy of. Make sure it's ending up in your engineering folder. First thing you do is you put your name and today's date in the heading tab. Then you go to flight data. I have some fake data here, so you're going to replace all of this. So you'd put your actual time in seconds and your actual distance in feet. We'll do a estimation of distance based on just looking at the floor. We're not going to actually drag a tape measure out every time it lands. I don't think we would have to do that with everybody testing. But you'll record your time and your distance here. The velocity will automatically be calculated. And then you need to add some notes here if it was turning to the left, if it was stalling, if it didn't go in a nice stable flight, what was the problem? What did you have to change to make it better? There are 25 test flights here. I expect you to complete that number of flights. It's going to take a lot of time to do that, and you really need a partner to help you so you can work efficiently. And then down here, it will automatically calculate your mean and standard deviation and max based on these numbers. You need to make sure if you didn't use all these data rows, so if you run out of time, you need to select the content in the rows that you didn't finish and delete the content so that these values are meaningful. And then you have conclusion questions you'll answer. On this, you have the area evaluation number. You can read these. So you'll answer all of those. Also, I want to do a comparison to see if ARI makes a difference or not as far as evaluation. So you're going to click on this little Google form and report a few metrics there for me. Then the final thing you're going to do is choose File and download PDF document. So I'll have a few settings here that I want you to make sure you do. Instead of current sheet, you need to make sure it says workbook, make sure it says all sheets, make sure it says portrait. It won't fit on landscape, so we're going to put portrait. And what that does is we end up with 3 pages of useful information. I'm going to delete this one. These don't change on headers and footers. Make sure all of these are checked, and that way it gives me some information about what I'm looking at and when it was printed and that sort of thing. So make sure all of those are checked. When you're done, you just hit export and it will make a PDF for you that's easy for me to follow. So I hope this helps you. Look forward to seeing your gliders.